This video is about the vector lab. In this lab, you were given some values for the vectors, such as here, given the x and y components, and you are asked to determine the missing values. So for example, here, the magnitude and the angle. Sometimes you're given as was set to, you're given the magnitude and the angle, and you're asked to find the components. Or perhaps you're given the angle and one of the components, and you're asked to determine the missing component and the magnitude. And then down here, it's a little trickier down here, but you're given one of the components and the magnitude, and you've got to figure out the missing component and the angle. This one's a little trickier, so I'm going to talk about this one a little later. Right now I'm going to focus up here on the main table, and also point out that you are also asked to determine the angle of the anti-parallel vector, which is represented with negative a. Negative a has the same magnitude as a, but it's in the opposite direction. It's anti-parallel. And the other thing I want to point out is that the angles here that you are asked to give are, and it mentions it up here, but they are counterclockwise from the positive x-axis. So I want to go over, I'm going to do a few examples, kind of showing you how to go through and do this. I'm going to start by looking at 1b. In 1b, I'm given the x component and the y component. I need to find the magnitude and the angle. So my recommendation is start by drawing the vector. This vector is going to be in the fourth quadrant. It's got a positive x, negative y. That's the fourth quadrant. So I'm going to go down here, and I'm going to draw my vector. And I don't need to worry about the vector being exactly where it needs to be. It's just a general idea. So I have some idea, okay, it's in the fourth quadrant. Helps me to visualize what's going on. The other thing is, as I mentioned, the angle is measured counterclockwise from the positive x-axis. So the angle that I'm asked to find is that angle. That's the angle that I'm being asked to determine. Okay, let's start by getting the magnitude. So my vector, so to get the magnitude, by the way, we're going to use the Pythagorean theorem. And I've got 31 squared and negative 43 squared. And of course you need to plug this into your calculator. I want to point out that this negative can cause problems. If you just type in negative 43 into your calculator, in fact I'll type it into mine right now, and I square it. If I square negative 43 in my calculator, it comes back with negative 1,849. Now we all know that negatives, when you square them, become positive. But the calculator, based on order of operations, it doesn't square the negative. If you wanted to square the negative, you have to type it in the same way that I've written it here. Okay. That's rather cumbersome as far as typing into the calculator. I recommend that you use your knowledge of the fact that squaring a negative will make it positive, and instead of entering negative 43 into your calculator, just put 31 squared plus 43 squared. That's a much easier way, and not to mention it's less chance of you making a mistake. Also remember that the magnitude must be greater than the absolute value of either component. And essentially it's the hypotenuse, and as you know, the hypotenuse of a right triangle is the longest side, so this has to have the greatest absolute value. Of course, it's always positive. I'm only saying absolute value because the components you really need to take the absolute value of the components and compare them to this. Okay, but that's the magnitude. We're just using Pythagorean theorem, so that's the magnitude for 1b. Now I need to get the angle. So the formula that we have talked about is this one, theta equals arctangent of the y component over the x component. And that will give you this angle right here, the angle relative to the horizontal. So if I'm doing that here, I'm going to have the arctangent. Now since I'm taking the absolute value, it means I'm just ignoring the negatives. So it's going to be the absolute value, the arctangent of 43 over 31. So that's what I'm taking. Again, it's absolute value, right here, absolute value, so I just ignored this negative as a result. And when you take that when you take the arctangent, that gives you approximately 54.21 degrees. So that's this angle theta. Okay. But this bigger angle that I'm asked to find isn't theta, of course. It's this. But hopefully you can see that this angle plus theta has to equal 360. So in other words, the angle that I'm asked to find plus theta has to equal 360. And so if I put in the 54.21, it's easy to quickly solve for theta. And I'm just going to go ahead and write down the answer because it's just 360 minus the 54.21, and that's 305, essentially 305.79 degrees. There we go. That's the angle counterclockwise from the positive x-axis. And so that's the answer that I would put up here. Now, I also need to find the angle of the antiparallel vector. Now, the antiparallel vector is pointing this way. It's the exact opposite direction. And I need its angle also relative to the positive x-axis, so that's this angle right here. That's the angle that I need. And of course, the key thing here is that this vector is 180 degrees away from the original vector. These are supposed to be 180 degrees apart. So all I really need to do to get it is take 305.79 minus 180, and that gives me 125.79 degrees. That's all I need to do for that part. Okay, so now I want to take a look at 2a. I want to do 2a here. And in 2a, I am given the magnitude and the angle, and I need to get the components. Okay, so how am I going to do that? Well, as I said, I think the first thing to do is to draw, and I didn't take good look. Let me look closer at 2a. Okay, so 2a is at angle of 35 degrees, so that puts it in the first quadrant because it's 35 degrees from the positive x-axis. So here's the positive x-axis, 35 degrees, doesn't even get me here, right? This would be 90 degrees from the positive x-axis. So 35 degrees is just somewhere over here. That's 35 degrees right there. Now I want to get the x and y components. So if I'm doing that, I need to get the magnitude. I didn't write that. Magnitude is 113. Okay, so I know that for the x component, that's going to be plus or minus a times the cosine of theta, and ay is plus or minus a times the sine of theta. Now remember, the plus or minus is there because we have to choose, we have to identify whether the component is supposed to be positive or negative. In my case, my vector here is in the first quadrant, so both of my components should be positive. But if my component was, if my vector was in the second quadrant, I would choose negative here for the x component because this is a negative x component but a positive y. If it was down here, I would choose negative for both, and of course if it was in the fourth quadrant, negative y but positive x. Okay. So these are the fundamental formulas we're using, but in this case, my component is 113. I'm taking the cosine of 35. I said the magnitude. I should have said the magnitude is 113, and I'm choosing the positive, not the negative. And this works out to be approximately 64.81 for the y component. And for the x component, 92.56 approximately. So that's how I get the components. Now I still need to get the angle for the antiparallel vector. Again, my antiparallel vector is going to be pointing down here, the exact opposite direction. And the angle that I need to find is counterclockwise from the positive x-axis. So that's the angle I need right there. Again, this vector, it's anti-parallel to my original one, so these are 180 degrees apart. So here I subtracted. And I think I neglected to mention it, but one of the reasons I subtracted here is because we can't have angles greater than 360. I could have added, but then I would have had an angle greater than 360. So here, though, I'm starting at 35. So for this case, I actually do want to add. So for this one, I'm going to take 35 plus 180, which of course is 215 degrees, which of course does put me in the third quadrant as expected. And again, let me go over this one more time to make sure I'm being clear. Here I added, because adding 180 to 35 doesn't put me over 360. Here I subtracted, because if I add 180 to 305, I'm going to be over 360. Now you could do that. I could have gone 305.79 plus 180. Okay, then I'd have 485.79. But then you'd have to subtract 360 from that. Okay, and if you do that, then you get the answer 125.79. These angles that you're stating in this lab are between 0 and, well, 360, although it's up to 360, not 360 itself. So you don't want anything greater than that. You don't want any angles 360 or greater. Okay, the last thing that I want to talk about is sets 5 and 6. Now, as I already mentioned, here you're given a component and a magnitude in these two sets. You're given a component and a magnitude. And you have to determine the angle and the other component. The problem here is that this is not enough information to definitively say what this component is. So if I'm doing the Pythagorean theorem, as I did before, and let me go ahead and erase this. So if I'm doing the Pythagorean theorem, and I'm solving for ay, I'm going to have a squared minus ax squared, and I'm going to take the square root of that, and that's going to give me ay. But the square root is a multi-valued function. It could be plus or minus. So we cannot definitively say, based on the information given, what the y component is. And that's why there are two spaces here. One for when the y component is positive, so you put a positive value here, and then you'd put the negative value here. And then you're going to have to determine the angle when you're using the positive y component, and the angle for the negative y component. And the same thing here for the angle of the antiparallel vector. So if I was doing that here, I'll just go ahead and work this out a little bit. So I'm going to have plus or minus the square root of, let's see, this is going to be 47 squared minus negative 27 squared. Okay. And so that's going to be plus or minus 27 squared plus or minus, plus or minus 38.47. So this is my y components. I should say these are my y components, plus or minus 38.47. So I would put positive 38.47 up here, negative 38.47 right here. Now I'm going to go through and figure out the angles. And when I'm figuring out the angles, I'm going to set it up here. So I'm taking the arctangent. Let's see, so that's going to be, the y component is 38.47. The x component is 27. I don't worry about the negative because I'm taking the absolute value. Okay. And when I do the arctangent of that, I get 54.94. Oops. So that's the angle. Now, the thing is, you have to go back to drawing the vectors. There are two possibilities here for my vectors, and let me show you. So let me erase all this. Oops, a little too much there. Okay. So let's see, I've got a negative x component, and I could have a positive y component. So negative x, positive y puts me in the second quadrant. So my vector could be pointing up this way. And in that case, this 54.94 degrees, that would be this angle right here. This angle, that would be relative to the horizontal, 54.94 degrees. So this is the case where I have the positive x component. Now, what about the case where I have the negative, I'm sorry, that's the positive y component. I said the wrong thing. I said positive x, I meant positive y. That's the positive y component. So this is the positive y component. Okay, so I'll put plus ay. Okay, but what about the case where I have negative ay? Down here. And actually, let me do that in a different color so there's no confusion. Negative ay. Okay, so, well, in that case, now it's down here like this. Okay? And this angle here is 54.94 degrees. The angle relative to the horizontal. And the angles that I have to enter into WebAssign, remember, come counterclockwise from the positive x-axis. So for the negative y component, I'd have to go all the way around like this. So I'm going to have to go 90, 180, 180, and then plus that 54.94. Whereas for the other one, for the positive y component case, I have to go from here to here. So in other words, I've got to go 90 and then this extra little bit. So I'd have to figure out what this extra little bit is, which isn't too hard because I know this. Or alternatively, I could go 180 minus 54.94 to get those angles. And then, as if that weren't enough, then I've got to draw the anti-parallel vectors for both of these, and I've got to figure out the angles for those using the same techniques that we've already discussed here. That's the idea with this lab. It's getting used to these vector quantities, taking the information that you're given, all this information that you're given, taking it and using it to help figure out what you don't know yet, and also to figure out the angle of the anti-parallel vector. And again, I definitely recommend drawing out the vectors. It's until you're highly skilled at this, until you have a lot of practice, this makes it so much easier. It's almost impossible to get these answers correctly if you're not drawing out the vectors.